Hey, what's up everyone? In this video, I'm going to show you how you can perform a laser alignment on the Sartorius iQue flow cytometer using the fluorescent QC beads to perform the adjustment as a calibration standard. So you can see here, I have built the QC experiment because in the new software on Foresight, the QC run is part of a wizard where you can't view the data as it's acquired, and so you'll need to build an experiment. And you can see here, here's the data from a previous run. It looks good, although the forward side scatter um, doublet looks a little funky, and also the RL1 CV is over 5. It's at 7. You can see it right there, which is out of spec. And if we look down at the histogram, you can see that the peaks don't look good. They're asymmetrical. They've got a tail on the front, and so it's clear that this is going to require a alignment for the red laser. And that's what I'm going to show you guys how to do. Everything else, again, the percent of this singlet beads is good. The blue laser CV looks good. If we zoom out on the density plot for the doublet, you can see that there is a little bit of a tail going on, which is indicative potentially of air in the system, but again, everything else looks really good. We're going to be focusing on the red laser for this video. As I said, you're going to need to build the QC experiment in Foresight. So you're going to need, here's the protocol for it, and you can see you're going to need to match all these parameters. Now you can pull this, if you look at the QC run during the wizard, you can pull these parameters from that, but you're going to need to replicate this. You can make some slight changes, such as the acquisition time, so you can actually run this a bit longer if you'd like. And this is, again, while the QC is running normally, you can pull this in the run progress, all the steps, so that you can replicate it as an experiment. You're going to need to do that so that you can watch the data as it progresses and make changes. And here's the new experiment that I built that we're going to run shortly. But this is the QC beads, and I've actually doubled the amount, so it's instead of 2 to 3 drops in 300 microliters, this is 6 drops in 600 microliters. So because normally this can take quite some time, you'll have to keep making adjustments and continually running the QC, so it just makes it easier, so you don't have to keep preparing new beads. You're going to put it into service mode, so you're going to press the tool tab, and then hold the control key down and then enable it. Now I just couldn't show that on camera, but that's what I did here. And then you're going to go down to iQue Screener plus Detector, go to Detector Calibration Mode, and then you're going to enable Detector Calibration Mode, and then click OK. And then this is what really makes this possible, this button with the C on it. Basically, this button will, when you click it, it refreshes the data as it's being acquired. And so it erases the old data, and then only the newest data is shown. So that way, when you make an adjustment, you're only looking at the data post-adjustment, because if we didn't do that and you made an adjustment, for example, this peak here of interest, it would just get really messy. You wouldn't be able to resolve your change versus the old data. So you really need to be able to do this in order to perform the alignment by pressing that C button. That's probably the most critical part of this entire thing. And now you can see here, this is the stage that we're going to be adjusting. And I just have a little tool, and look, I'm making an adjustment. I'm pulling that clockwise while the QC is running. And so I'm going to press the C button right now. And now that you can see that the data has been erased, and now it's acquiring new data. And after that adjustment, you can look now, look at that peak. It has gotten much more symmetrical. The CV has fallen into line. Now it's below 5. It's at roughly 3.5. And now look, the peak again looks very symmetrical. This is exactly what we want. And actually, I'm a bit surprised at how quick this took, because normally it can take a lot longer. It's very easy to overshoot when you're making these adjustments, you need to be make very minor adjustments. And even if we look at the density plot for forward scatter versus side scatter, the doublet looks a lot, that data looks a lot better. So this is probably going to be the final adjustment um, that I'll make now that the CVA has fallen below 5%, and that's just the coefficient of variation. So that's basically signifying the broadness of the peak. And so that looks really good. Everything else looks really good. So this is, like I said, going to be the last adjustment. And as the run progresses, the data is still looking good. So this is exactly what we want. And now the unit is just performing the final clean steps. And again, this stage here with my little tool, this is just an Allen wrench that fits into a little hole. It's not, you can use any tool that will fit in that hole that makes this easier to adjust. And you can, as I said, I moved it in the clockwise position, but it's not always going to be moving it clockwise, or it could be counterclockwise depending on where that has fallen out of alignment. And then I ran the QC again. This is just the final QC using the actual wizard. So now you can see it's providing you pass-fail results, and you can see the CV bumped up a little bit to 4.2. We probably could have dialed it in a bit more, but as you get closer and closer, it gets very easy to overshoot it. And so, I'll continue to monitor this, and if we start seeing a trend higher again, we'll make another adjustment. But this should be good as long as the instrument is in an area with no vibration. This should be good for a while. You don't have to adjust these very often. But yeah, again, putting this thing into service mode like I showed you, building the experiment, the QC experiment, and then using that C button to refresh the data. Those are the key points of this video. So yeah, not too difficult to do. It does take a little bit of practice, and I can understand if you'd be unwilling to do this, but I'm hoping that this will give you guys the ability to do this yourselves. This is how you calibrate this instrument, manually calibrate it, or make a calibration adjustment. Hope you guys found that interesting, and if you have any feedback, leave it in the comments.